Hello, in this video I'm going to show you how to write automated tests for Roslyn analyzers. I'm going to write automated tests for the analyzer I wrote in the previous video to show examples. Okay, let's get started. So in the previous video I ended up with this immutable array analyzer project, which is a VSIX project. One problem I faced when trying to test this VSIX project is that once Visual Studio packages the output of this project as a VSIX file, for some reason it deletes the DLL file of this project, and thus writing tests against this project didn't work for me. So what I'm going to do is create another project, a class library, and move the analyzer class into that class library and keep this project only for deployment. And then I will write tests against the creation analyzer class, which will be in the new class library. Okay. Okay, I'm creating a new project. I'm calling it analyzer project, which is of type class library. Okay, let me move this creation analyzer here and delete this class 1 file. Okay, so one thing I need to do is I need to go to this source.extension.vsix manifest file and go to assets, update this asset here to use the new project. Okay, let me delete this class from this project. Let me go to this project, add the required NuGet packages. I'm also going to fix the namespace here. Okay, now we are ready to create the testing project. I'm going to add a new project, a unit test project. Now this unit test project will use MS Test by default, but you can use any other framework if you want. Okay. And let me add the NuGet packages. Okay. I'm also going to add a reference to the analyzer project. So what am I going to do in this test? What I'm going to do is I'm going to create a C# solution in memory, of course. I'm going to create a project inside that solution. Inside that project I'm going to create a C# file. That C# file will contain some code, and then I will ask the analyzer that we built to analyze that file and report diagnostics. Then I will make assertions against these diagnostics. Let's see how this happens. Okay, so what I'm going to do, I'm going to create an instance of a class called ad hoc workspace class. So what's an ad hoc workspace? An ad hoc workspace is a special workspace that lives in memory. This is different from other kinds of workspaces, like the one here in Visual Studio. For example, currently I have this solution open, right? Let me show you the solution here. So here I have this solution open, and there's a real workspace here, right, that contains this solution, and this solution is written to the disk. The ad hoc workspace class here is similar to this workspace, right, in that it contains a solution and the solution can contain projects, but this workspace is completely in memory and I can use it in automated tests, for example. Okay, so the workspace object here has a property called current solution, and it returns an object of type solution. And this property is called current solution because there are ways to change the solution in the workspace. So in this sense, the workspace object is a mutable object. Now the solution here is going to be an empty solution because this is a new workspace. Okay, what I'm going to do next is create a project inside this solution. Okay, I have created a new project ID. Okay, so I have created a new project in this solution. I called the project my test project, and the assembly name is going to be my test project. And the language I chose, of course, is C#. Now the solution object is an immutable object. That is, we cannot change the contents of a solution object. Instead, we can create a modified version of the solution object. So here I assigned the new solution object, the modified object, to the same variable, but of course I can assign it to another variable if I want. Okay. So now the solution variable is pointing to a new solution object. Okay, what I'm going to do next is add a new document to the project. Okay, the document ID is document ID dot create new ID, and I'm going to give it the project ID. This will be used to indicate that the added document will be put in this project. Okay, the document name is file.cs, and then the text. For now, let me put an empty string. Okay, so what this will do is it will create a new solution object containing a new project object which contains a new document object with the following code. Of course, here I'm going to put the new code. Okay, let me put this inside a variable. Okay. What I'm going to do next is that I'm going to get the project object and from that I'm going to get a compilation. Okay, get compilation async. Okay, so I'm going to await this because this is an async method. Okay, the await doesn't work here because this method is synchronous. Okay. Okay. You can think of this compilation object as the result of compiling this project here. This, however, doesn't produce a DLL or an exe like we are used to when compiling a project, but this compilation object will enable us to obtain semantic models for the code files in the project. I will talk about semantic models later. Okay, so before I continue, I want to show you something. I'm going to call a method in the compilation object called getDiagnostics, and this will return an immutable array of a diagnostic object, and we are already familiar with these objects. So this will be the result of the built-in analyzers in C#, right? So now we expect this diagnostics array to be empty, right? So the test is not complete yet because we still didn't attach our analyzer to the compilation, but I'm going to show you something first here. Okay, let me run the test, and it's going to fail, and I will explain why. Okay, it failed, and the actual number of diagnostic objects is 2. So let me debug this test here. And let me view the diagnostic objects. So here we have two errors. And one error says predefined type system.object is not defined or imported. And the reason we have this error is that we have not referenced the MS-Core-lib library into our project. So by default, each project will have 0 references, and this is not the case when we add a new project here, right? When we add a project here, there are some default references added to us by Visual Studio, but when we are adding the project via Roslyn here, we must add these references ourselves. So what I'm going to do now is I'm going to add a reference to mscorelib.dll. So let me explain this code. Here I'm calling a method called add metadata reference, and I'm giving it the path of mscorelib.dll. Now the way I'm obtaining this path is using the object type, because I know that the object type exists in mscorelib.dll, because this is a .NET Framework project. From that I'm getting the assembly, which is mscorelib, and then the location, which is the location of mscorelib in my computer. Now because the project class is immutable, I cannot update the project itself. I can create an updated project and then assign it to the same variable. So the variable itself here is mutable, but the objects here are immutable. So now if we run the test, it passes. However, this is not the test that we want to write. Currently this test doesn't involve the analyzer that we are creating. It simply makes sure that this empty code compiles. So what I'm going to do now is I'm going to create another compilation object that includes our analyzer. And then I'm going to get the diagnostics from this new compilation. So this object is of type not compilation, but compilation with analyzers, and the method we use to get the diagnostics is called getAllDiagnosticsAsync, and this is an async method, so I'm going to await it. Here we still want to make sure that the diagnostics array is empty, because this code here doesn't contain any creations of immutable array via the empty property. So basically this is the initial test, and it tests the very basic scenario, that is, with an empty main method here we don't report any diagnostics. Okay, the test passes. Okay, before I start writing the next test, I'm going to do some refactoring. I'm going to extract most of the code here into its own method so I can reuse it. Let me show you. Okay, so let me show you the extracted method here. It takes a piece of code, it creates the workspace, gets the solution, creates the project like we did before, updates the solution with the new document containing this code, adding the metadata reference to the project, mscorelib here, creates a compilation object, and then creates another compilation object with our analyzer added to it, getting all diagnostic objects and then returning them. Okay, now our test is smaller and only the relevant parts are in the test itself. Okay, so let me rename this test here. Okay, and let me create the second test. Let me call this one creating an immutable array via the empty property generates one diagnostic. Okay, so before I continue, in order for the project created in this getDiagnostics method, the one here, in order for our code to compile, the project also needs to reference all needed DLLs for the immutable array class. So I have created a method called getAllReferences needed for type. You give this method a type and it gives you back all the metadata references needed in order to use this type. And this method works by getting the assembly of the type, also all the assemblies referenced by this assembly, and then getting the locations of all these assemblies. So what I'm going to do next, I'm going to add all the metadata references needed to use the immutable array class. Okay, now back to the test. Here we expect that we will get a single diagnostic object, right? So let me get this diagnostic object. So here we expect that the diagnostic ID would be bad way of creating immutable array. Okay, so let me run this test. Okay, the test passes. So one good practice to do when creating automated tests is to see a test failed. So what I'm going to do, I'm going to change the code of the analyzer in order to make this test fail. And the reason I'm going to do this is, if you only see a test green, you will never really know that it does actually test the system, because it could be passing by chance. Okay, I'm going to the analyzer and I'm going to change the ID of the diagnostic descriptor. I'm just going to add one here. I'm going to the test, I'm going to run it again. Okay, the test failed, so now we can trust the test. Okay, let me run it again. It should now pass. Okay. Another thing I want to verify in this test is the location of the diagnostic. One property of the location is called source span, and this source span will give us the start and end positions of the location. But these start and end positions are in terms of character offset between the beginning of the file and the position. So for example, the start position here would be the number of characters here, right? And the end position would be the number of characters here, right? Another interesting kind of span is called a line span, and I can access it using this getLineSpan method. The start and end positions of this line span are in terms of line and character. That is, the start position of this span here will contain the line 7 here, because we have line 0, 1, 2, 3, 4, 5, 6, and 7. and then the character will be the offset of this character here within this line. Okay, so what I'm going to do here, I'm going to assert that the diagnostic will be on line 7. Let me run the test. Okay, and the test passes. Here we can do the same thing that we did when we added this assertion, that is, we can now make the test fail by changing the creation analyzer and then make it pass again by fixing the creation analyzer. Okay, now let me write a test that will fail. So in this test, I will not open the system.collections.immutable namespace like we did in the previous test. Instead, I'm going to reference the immutable array type using its full name. Now we expect also that the analyzer would generate a diagnostic, but instead of line 7 here, we expect it to be 0, 1, 2, 3, 4, and 5. And let's run the test. Okay, the test fails because the creation analyzer, as we wrote it in the previous video, doesn't handle this case. So in this video I have showed you how to write the tests, and in the next video I will show you how to fix the creation analyzer in order to handle this case here. Okay, thank you for watching.